Boston Dynamics just made Atlas perform clean cartwheels, controlled backflips, and mid-step balance recoveries that look almost human. At the exact same time in China, humanoid robots are performing kung fu alongside real Shaolin monks, not as a gimmick, but in synchronized motion. And while that's happening, a US company just put humanoid robots up for sale with real prices, real deposits, and real delivery dates. So here's the question no one is asking clearly enough. Are we watching the final chapter of humanoid testing and the first chapter of humanoid deployment? Today we're breaking down three major shifts: Boston Dynamics pushing physical intelligence to its limits, China scaling synchronized embodied AI, and commercial humanoids entering the market. This isn't about cool demos anymore. This is about readiness. Let's start in the United States. Development Boston Dynamics. From research to reality, Boston Dynamics just released what feels like the final stress test of its research version of Atlas. The video starts calmly. Atlas walks across an open area with a natural gait. The posture is stable. The movement is fluid. There's no stiff robotic stiffness we used to see in early humanoids. Then the intensity spikes. A sideways cartwheel, immediate transition into a backflip, clean rotation, stable to foot landing. But here's what actually matters. It's not the flip, it's the landing control. You can see controlled force absorption through the legs and torso. Instead of crashing down, Atlas distributes impact like an athlete. Even more important are the bloopers. There are moments where Atlas missteps, slight foot misplacement, minor instability, but then it corrects in real time and keeps moving. That's dynamic feedback control. That's whole body coordination. That's not pre-scripted animation. So what changed? Boston Dynamics partnered with the Robotics and AI Institute, led by Mark Rabert, the founder of Boston Dynamics himself. They're using a unified whole body learning framework. One system, not one model for walking, not another for flipping. Everything is trained together. And here's the breakthrough: zero shots into real transfer. The control policies are trained in simulation and deployed directly onto the real robot with minimal tuning. In robotics, sim-to-real transfer has always been a bottleneck. Simulation physics rarely match reality perfectly. So when a robot performs dynamic gymnastic movements trained mostly in simulation, that's a milestone. But here's the bigger picture. Research Atlas is winding down. Enterprise Atlas is coming. The production version has 56 degrees of freedom and a highly advanced tactile sensing gripper designed for industrial manipulation. Hyundai Motor Group plans deployment at Metaplant America by 2028. Initial tasks: part sequencing. By 2030, full component assembly. So those flips aren't just for viral clips. They're proving control reliability under extreme stress, the kind of stress industrial environments demand. Now zoom out, because while the US is refining physical intelligence, China is scaling coordinated humanoid systems. Agibot, scaling embodied intelligence. Chinese robotics company Agibot released footage of humanoid robots training kung fu at the Shaolin Temple. That location choice is intentional. Shaolin represents centuries of disciplined human motion and balance control. And now robots are replicating it. Synchronized kicks, precise punches, stable stances, coordinated movement with real monks. This isn't a random stunt. It builds on earlier demonstrations. In 2025, Agibot's Lingxi X to humanoid performed cycling tasks and later executed a Webster flip, a forward somersault requiring tight mid-air control. So what powers this? Genie Operator 1, also known as GO1. This system uses zero-sample generalization. That means the robot can manipulate objects or perform actions it hasn't been explicitly trained for. But the real innovation is latent action modeling. Instead of relying on massive labeled motion datasets, the system analyzes visual frame sequences and infers motion patterns. Why does that matter? Because high-quality labeled human action data is scarce. If robots can learn from observation rather than exhaustive labeling, scaling becomes much faster. There's also multi-agent synchronization. In the Shaolin video and later at Agibot Night in Shanghai, Multiple humanoids move in coordinated formations. 16 robots performed in a 60-minute gala, dance, music, comedy, flips, runway-style walks. One robot doing a trick is impressive. 16 robots performing continuously in tight coordination for an hour? That's systems engineering at scale. It demonstrates stability, timing synchronization, and sustained performance under real-world conditions. Agibot showcased multiple product lines, the A2 series for multimodal interaction and navigation, the X2 series for expressive movement and education, the G2 series for industrial force-controlled handling, the Dun quadrupes for inspection tasks. This wasn't entertainment alone. It was a systems validation event. Now here's where the narrative shifts. From performance to purchase. Faraday Future, commercial humanoids Faraday Future, known primarily for electric vehicles, officially entered robotics at the NADA show in Las Vegas. They introduced 3 embodied AI products: FF Futurist, full-size professional humanoid; FF Master, athletic interactive humanoid; FX Aegis, quadruped platform. And this is where things get serious. They're for sale. Futurist starts at $34,990. Master starts at $19,990. Aegis starts at $2,499. Non-binding deposits are already in place. Initial deliveries are targeted for February 2026. Faraday Future claims over 1,200 B2B units are covered by deposits. This is no longer theoretical. This is commercialization. They're building a 3-in-1 embodied AI ecosystem, hardware devices, an open AI brain platform, a decentralized data factory for continuous learning. The strategy mirrors scaling, shared software architecture, shared manufacturing, modular upgrades, and the timing aligns with broader trends. Large language models are mature, edge compute is improving, battery density is increasing, on-device AI is accelerating. Physical intelligence was the missing link. Now it's emerging. Conclusion: so what are we really seeing? Boston Dynamics is finalizing high-performance physical intelligence for industrial deployment. China is demonstrating synchronized multi-robot coordination at scale. And commercial players are putting humanoids on the market with clear pricing and timelines. The testing era is closing. The deployment era is beginning. But here's the deeper question. What industry changes first? Manufacturing? Logistics? Hospitality? Security? Education? Because once reliability crosses a critical threshold, adoption doesn't grow slowly. It scales, and this time, it's not just software scaling across servers. It's physical intelligence entering the real economy. We're not watching isolated robotics demos anymore. We're watching the early phase of embodied AI integration. The next 5 years won't be about whether humanoids can flip. They'll be about whether humanoids can work. And once that answer becomes yes, everything shifts. I'll see you in the next one.